Hi, I'm Tom Corcoran with Red Hat 3scale. I'd like to demonstrate a solution that enables almost latency-free API management, suitable for Java-based microservice APIs. We build on my colleague Manfred Bortenschlager's white paper, Achieving Enterprise Agility with Microservices and API Management. The white paper is available on the 3scale website, 3scale.net. Here we provide a practical solution for adding the management layer Manfred outlines to internal microservice-to-microservice API calls. In this diagram from Manfred's white paper, we see a typical microservices architecture with depictions of externally and internally consumable microservices. In the white paper, Manfred describes a common architecture consisting of a perimeter service layer, which is typically implemented by an API gateway. The gateway manages and secures components that follow the back-end for front-end pattern. This perimeter service exposes APIs to external consumers. We also have these internal microservices that are clustered into functional elements and communicate via APIs. The most common and most decoupled way to achieve API management is through deployment of API gateways on the API provider's infrastructure. These gateways act as traffic controllers, which authenticate, authorize, and report on API traffic to the 3scale API management platform. These extensive management features are achievable with very low latency overhead through our caching and asynchronous architecture, which we'll describe shortly. Additionally, gateways provide excellent routing and security protections, such as defense against DDoS attacks and more. So using an API gateway is the most popular means of integrating APIs with 3scale. In certain situations, however, where the traffic has already been authenticated, or where low latency is absolutely critical, like in microservices-based architectures, an alternative to API gateways is appropriate. To add context, we'll describe how 3scale conceptually achieves its low latencies in the API gateway, which is relevant to our solution. Here we can see the UML describing externally originating API calls routed through the gateway. Essentially, an API call is sent from the client application, mobile app, web app, IoT device, etc. Instead of routing the call directly at the API, the call is directed to the gateway, where communication is made to 3scale to authenticate, authorize, and report the call. So it's registered and later viewable in the analytics component of the 3scale API management solution. What enables our low latencies is the nature of the communication between the gateway and the 3scale platform. To elaborate on that, as soon as a call reaches the gateway, the local cache is examined for the presence of 200. 200 is a code described in the HTTP standard that stands for OK. So the gateway looks for this 200, stored against the incoming API key, concatenated to the 3scale identifier of the API resource being hit. If this 200 is present, the call is allowed straight through to the API backend, and 3scale is contacted asynchronously. That is, after the call was forwarded to the customer's API backend. The cache is updated with the result of this authorize and report call to 3scale. If 200 is not present, in the case of an empty cache entry or 403 where the previous call was unauthorized, there's a synchronous or blocking call made to 3scale. But as most calls do encounter this 200, most calls are simply allowed straight through, resulting in our low latency solution, typically adding an impressively low 10 to 20 milliseconds onto the latency of an API call without API management. In addition to the API gateway solution just described, we're proposing a refined solution with even less latency. It's especially suited for internal API-based microservice-to-microservice communication. 3scale exposes various code plugins to enable authorize and reporting calls to be made from your own code base. One of these is the Java plugin, available here on github.com 3scale 3scale WS API for Java. For today's solution, we've taken this plugin and surrounded it with a wrapper. In it, we use the exact same behavior we just described on the gateway. That is, the incoming call checks the local cache, in our case a Java hash map, for the presence of the incoming API key concatenated to the 3scale identifier of the API resource being hit, with a true stored against it. True indicates the previous call by this client to this resource was authorized by 3scale. If true is found, we allow the call straight through and make an asynchronous authorizing and reporting call to 3scale. If true is not found, we make a synchronous or blocking call to 3scale. So you can see the diagram contains a UML describing the solution. The solution is available also on GitHub at TNS Corcoran 3scale Java plugin wrapper. We put the code and the instructions on this GitHub repo. You simply download the 3scale Java plugin, download this plugin wrapper, both Maven projects, make a couple of customizations applying it to your 3scale account, and install. The calls to the wrapper could be from the API code itself, could be from a servlet filter, interceptor, aspect, or other cross-cutting concern. The choice is up to the implementer. As an illustration of the low latencies achievable, I have two implementations of a mock endpoint running on a local Tomcat server. The endpoint is /catalog/product, one of the services used as an example in Manfred's Microservices article. This endpoint is called by another microservice, therefore it's applicable to this use case. So like I say, I have two endpoints set up for this test. Endpoint 1 is a simple implementation that returns some product data. Endpoint 2 is an identical implementation to 1 that includes a call to the Java plugin wrapper to add API management to this service. Now for the demo. We can see here that we have my first call without API management. We have 1,000 requests set up. That's 10 threads, each with 100 requests. If we fire those at the local Tomcat endpoint, you can see it builds up to 1,000 and it's very low latency, which reports at an average of 0 milliseconds. Now we're going to switch to do our managed test using the 3scale Java plugin wrapper. But before we do that, let's visit 3scale Analytics. We want to establish the baseline before our test. So you can see that in the last day, my API has been hit 17,000 times. Now, to switch back, we have my managed test set up again with 1,000 requests. And if we fire those at the local API, we can see that we achieved this with an average of 2 milliseconds. That's 2 milliseconds above what it would take to hit the API directly. And we can see that we successfully return data in each of our 1,000 requests. Just to complete the picture, if we switch back to the 3scale Analytics and we refresh here, this 17,000 should go up to 18,000, which it does, indicating that these calls have been managed and reported to 3scale. So, in conclusion, the API gateway is generally how we recommend integrating your API with 3scale. In certain cases, however, particularly for internal microservice to microservice API calls, there's benefit to utilizing the 3scale Java plugin wrapper solution. This allows us to leverage the superb API management capabilities offered by 3scale at extremely low latencies. So, for more on Red Hat 3scale, see 3scale.net. Thanks for watching.